Hello, everybody. It is Andrew in here, and welcome back to the channel. Today, we are going to be technically starting our first lesson on AOPS Intermediate Algebra. Again, as I have said in the preview, most of the first four chapters is review, and thus, this section is going to just be covering more of the topics of like an introduction to algebra. Anyway, let's start. It's Unit 1, Section 1, Isolation. Before we actually get into the content though, I do have a disclaimer, and that is that first of all, my methods that I use in solving the problems of this book are not always like the most accurate or like the best suitable for you. So just take this as a grain of salt. And also, I myself do make a lot of mistakes, so if you guys see any, just please correct me. I'm very sorry if I actually make a mistake, and don't be afraid to post any mistakes in the comments section. Okay, then let's get started. Here are some tips to remember. So, first of all, when we solve equations, we have to isolate them. We can add, subtract, multiply, divide, square root to both sides of an equation and still not change its value. That's how we isolate the equation. Well, a cool trick is that when adding or subtracting to both sides, for example, x plus 5 equals to 5, when you're subtracting 5 from both sides, technically the plus 5 on the left gets cancelled out, but also we have to subtract 5 to the right side. That we can visualize this as moving the 5 from the left side to the right side and changing the sign. And that is basically one of the tactics to just quickly add and subtract to both sides. And I'll be using that along with my problems. So yeah. Now, the second tip is that the transitive property, which is a property out there, shows that if A equals to B equals to C, or A is smaller than B or is smaller than C, then A would equal to B or A is smaller than B and B equals to C or B is smaller than C. Again, this works for both equations and inequality chains, so that will become very handy dandy when we get to our problems. Now, the last tip to remember is that when we're solving inequalities, multiplying, dividing a negative number to both sides of the inequality reverses the sign. So that is a thing to remember, as a lot of people would probably forget that, and sometimes including me. Now, let's move on to the problems. Here are the two problems that I present to you first. I'll give you guys a second to like jot them down and pause the video. Well, I'm gonna move on to the solutions. The solutions are over here. So this is just basically solving multi-step single variable equations. This is we can combine like terms for these two, and that becomes 5r. We move the r over, reversing the sign, making it positive r. That would be 6r. We move the negative 2 over, and that becomes positive 2. So 7 plus 2 plus 3 basically is 12, and r is 2. Again, I may have made mistakes, but a good way to double check, is to plug the value of r, do some plug-and-chug substitution back into the equation, and see if it creates a true statement. If it does, then that means we're correct. For the second problem, we use some distributive property. As you can see, we have the 3 times t minus 9. We distribute the terms over 3, we get 3t minus 27. keep track of signs, and then we move the 2t divided by 3 over here, and move the 27 over, which gives us 34, and then we flip the equation, and so that it's easier to visualize. 3t minus 2t divided by 3 equals to 34. Now we simplify the left side to get 7 divided by 3 times t equals to 34. And then we get t equals to multiply the reciprocal, t equals to 102 divided by 7. The next set of problems I'm going to present to you are over here. It's all about inequalities now. So switch gears, and now after jotting down these questions, I'm going to share the solutions. For the first one, we use the same tactic as equations, and we get negative 8 is greater than or equal to 4x, moving the 4x over. We flip the inequality, reverse the sign. So that means 4x is smaller than or equal to negative 8, and x is smaller than or equal to negative 2. For the second inequality, it's the same deal. We just basically combine the t and move them to one side while the numbers to the other. Then we divide by a negative number, so we have to reverse the sign. T is greater than 2. For this last inequality, it's, as you guys have seen, it's one of the star questions. And this is important because if you guys were listening at the beginning, I told you about the transitive property, which helps you basically break this inequality chain down into these two separate inequalities, solve for each, and you get these two smaller inequalities, group them back together, and we get negative 4 divided by 7 is smaller than x, which is smaller than or equal to 1/5. That means that x is in the range of negative 4 over 7 and 1/5, which is included. And that's just interval notation, and that's basically a more organized way of just representing the solutions to an inequality. For the next problem, it's a special case equation. You guys probably have seen this in like the 7th grade curriculum, and one important thing to remember is to make sure you include both the negative and positive results. Right over here, when you take the square root of both sides, the negative opposite of the square root of a number also produces the same square. So just remember to keep that in mind. And then let's move on to the next problem, which is this. This problem is basically treat these two. You see these two are denominators, right? They look like the same, and they are in fact the same. Treat them like the same denominator, like a common denominator. And with continuing that thought, let's get started on the solutions. We treat these two as the same common denominator, so we have to move these two over as kind of like terms and combine these two as we get some subtraction over here. So this would just basically be 3 minus 1 divided by this common denominator, which is 2. And then we can just multiply this nasty denominator out. And again, we can simplify just by dividing both sides by 2. And then we just get the square root of z minus 3 minus 1 equals to 1. And we solve for z by squaring both sides. But there is something to remember about extraneous solutions. We know that z must be greater than or equal to 3, or else the square root would take a negative value. And we aren't there to complex numbers just yet. It's in chapter 3, so for these two chapters, we can assume that we all want real solutions. So that is something to keep in mind. Well, then how does the square root of z minus 3 even disappear, like that hidden condition? Well, it's because when we square both sides, that square root just disappears, and z can be anything you'd like. So that's how we find the hidden condition in these, and just spot them. And remember, double check your work using substitution. That's the best way to check for extraneous solutions. But it's also important to spot these extraneous solutions, and those will keep you on your tippy toes so that and gear you to your right answer. And now we present to you the question of the day. Find this is really the one question that actually gives you some problem solving skills that you need to have. Here it's basically the question is find all values of c such that the equation has no solutions for x. No solutions. Usually when we solve an equation, we find the solutions. Now we want to find a value that doesn't give it solutions. Obviously, right off the bat, when we are looking for extraneous solutions, denominators cannot be 0. X cannot be 0. 2 minus 1 divided by x also can't be 0. That means x cannot be 0 or 1 half. So, but that doesn't really give us anything. Well, it does give us something, but we can't really directly use it. Like, look, if we just plug in the values of x, we won't get anything for c because they're all invalid. How about we try again? Remember the extraneous solution, extraneous thought that we're thinking about? How about we get rid of this hidden condition? And then we can plug in the values of x freely. Then we can find the values of c such that x equals those values. And then when plugged into the original equation, obviously give us no solutions. Continuing that thought, I'll present to you the solutions. So first, yeah, we get rid of the nasty denominator. Here's kind of the trick though. When we get rid of the nasty denominator, we only get rid of like one of the layers. We have to get rid of two of them. So we basically put the c, we multiply the c out. Like this is 2c minus c divided by x. Now we multiply by an x to both sides. And this becomes x times 3, and this is x times this thing that we just multiplied and distributed out. Now, why did we multiply by x? Because we want to get rid of this denominator as well. So we're getting rid of this denominator because these two cancel out. And this becomes 3x equals to 2cx minus c. Now, when you see this, we want to solve for x. So then we can plug in the values of x as there will not be any nasty denominator stopping us. Great idea. Let's start. So first of all, we want to put the x all over on one side, like how we isolate the variable. And by doing that, and rearranging, we get this equation right here. We factor out the x, and we get x times 2c minus 3 equals to c. Divide by 2c minus 3 to both sides, and there we have our x as an individual variable. And that means we can safely plug in our x. But first of all, before we do that, there's an even more obvious thing. We see that this has created a denominator for the c as well. 2c divided by 3 can't equal to 0. In other words, c can't equal to 3 halves. So we already found one solution. We have to find all the values of c. So basically, Now it's after doing that, we just substitute our values for x inside. For the first x equals to 1/2, we don't make any much progress because we find out that c doesn't have a solution for it either. But when we plug in x equals to 0, c does have a solution, and that is 0. So in the conclusion, we know that c cannot equal to 3/2 or 0, and that is the solution. Now, after we're done with all the questions, phew, now let's summarize all of them into a few key concepts right here. So first of all, our first key concept is that we solve equations by isolating the variable to one side and the numbers to the other side. This is the most basic part in solving an equation. The next one is that for inequalities, for compound inequalities, we can split them up and solve them separately. Or is it inequality chains, whatever. And then another key concept is that negative values also square to the same answer. When you're taking the square root of an equation, remember to include the plus minus. And our last and most important detail, be on the lookout for extraneous solutions. Basically, extraneous solutions are very important and because they actually get quite often when especially when you find like the domain and range of functions is always good to keep out for these as they can trip you when you're unexpected. And also just getting to know and understand these hidden conditions inside the problems can improve your problem solving skills and just make you understand the problem better. Okay, now after we have done all our problems, we present to you some homework. Well, it's not really homework, it's totally optional if you want to do any of it. It's just the exercises from the book. And I have already have them copied right here. You can pause the video for a sec to jot them down and just do them. And if you are indeed courageous or brave enough, please post your answers in the comments below. And if I have time, I will respond to your comments, probably. Okay, so let's go to the next slide. And next slide. And there, that's the end of the video. Thank you all for supporting my channel and thank you all for watching. See you next time.